Assalamu alaikum, dear students. I am Tahir Yusuf from GAK College. Today we are going to learn about the topic dimension, which is first year topic, and this is chapter 1, measurements. So let me start the topic dimension. In last video, we discussed about the physical quantity and the units of the physical quantity, SI units, and we discussed base units and drive units. So first, there is a difference between dimension and unit. A dimension, a dimension is a measure of physical variable. It's mean without numerical values. But unit is a way to assign a number or measurement to that dimension. For example, length is a dimension, but length is measured in the units of meter. So, dimension describe the nature of the physical quantity. There are only 7 base quantities. The first one is time, the second is length, and the third is mass. So today in this topic we describe only these 3, but there are 7 base quantities. We define time. The unit of time is second, and the unit of length is meter, and the unit of mass is kg. So we say that dimension is the study of nature of a physical quantity. So when we write the dimension of time, so we use some specific symbols. We use a specific symbol for time, that is capital T. For specific symbol of length is capital L, and for the mass is capital M, and we enclose these specific letters in square brackets. So square brackets denote the dimension of that quantity. So we can say that this is the dimension of time, this is the dimension of length, and this is the dimension of mass. So dimension, when we describe a physical quantity, when in the terms of base quantities with specified symbols, and that symbol is enclosed in a square bracket, this is called the dimensions in physics. So let me discuss how we derive the dimensions of other physical quantities. So I write the dimension of time, the dimension of length, and the dimension of mass. So we use these 3 terms and we derive the other dimension, like the dimension of area. So we can write the dimension of area. So the formula. Area is a derived quantity, and this is the combination of 2 base quantities, length multiplied by length. And when we write this, we enclose these terms. So this is meter square, and we can say that we denote the dimension, means we replace meter by capital L, So L square, this is the dimension of area. If we can write the dimension of volume is meter cube. So we can write this meter cube by, we used meter in terms of, we specified, give a specified symbol to meter, that is L cube. So this is the dimension of area and this is the dimension of volume. So these are the derived physical quantities and we describe these quantities in terms of this quantity. So the next term is dimension of density. So first you know about what is the formula of density, that is mass divided by volume. So the dimension of mass is capital M and the dimension of volume is L cube. So the whole formula or the dimension of density will becomes M L minus 3. So we move this L at the numerator and L3 becomes minus. So the dimension of the volume is ML minus 3. So we direct use when in paper they the question is find the dimension of a density. So you can write the direct value. This is right. This is for your remembrance. You remember how we find the dimension from formula or the base quantity. So you can write direct. If you remember the formula or the dimension of the density, you just write the dimension. So the next dimension for velocity. Dimension of velocity. You know, velocity is displacement per unit time. Displacement is also a base quantity which is meter, and we can say this is meter divided by second. So the dimension of meter is L and the dimension of time or second is T. So the dimension of velocity we can write here is Lt minus 1. L goes to numerator and the power plus 1 becomes minus. So this is the dimension of velocity. Now we can write the dimension of acceleration. The dimension of acceleration. So we can write direct, because you know acceleration is mass velocity per unit time. So the dimension of velocity is Lt minus 1 divided by time. This is the dimension of time. So the dimension of acceleration becomes Lt minus 2. This square brackets is very important. So these are the dimension. Now the other physical quantity which is called force. This is very important in exam. The examiner asks how you find the dimension of force. So let me find the dimension of force. You know the formula of force is F is equal to ma. M is the mass of the object and a is the acceleration. So you write the dimension of mass is capital M, and you also in previous you solve acceleration, dimension of acceleration, which is Lt minus 2. So this is the dimension of force, Mt minus 2. Now in your exercise, they ask for the dimension of pressure. Find the dimension of pressure. This is in your exercise. So, formula of pressure is force per unit area. Now, you can write the dimension of force from here. M L T minus 2, and area you find earlier, that is L square, meter square. So the formula for pressure become M L, this is plus 1 and this is minus 2, that is equal to T minus 2. So the dimension plus 1 minus 2, that is becomes L minus 1. So this is the dimension for pressure. This is also the dimension used for stress. This is also the dimension of stress. So stress and pressure both are same in dimension. Now the next term we use here, which is power. Power, find the dimension of power and find the dimension of work done. So first we find the dimension of work done. Work done, the formula for work done is F dot D, FD. F is the force and D is the displacement. So the formula for force or the dimension of the force is M L T minus 2, and the dimension of displacement is capital L. So it becomes, I can write here, M L square. So in multiplication, powers will be L. So L square, then T minus 2. This is the dimension of work done. So we know that the formula of the power is work done per unit time. So the dimension of the work done is M L square T minus 2 divided by T, and it becomes M L square T minus 3. This is minus 2, and when T becomes to the when we goes to numerator, that power of T becomes negative. So minus 2 minus 1 is minus 3. This is the dimension of power. So we can write these physical quantity in terms of base quantity with specified letters and enclosed in a square brackets. These are called the dimension of the quantity. So the one question is very important in every exam, or in most exam, or in your exam, or in your test, they ask derive a dimension for energy. So we can write the dimension of energy. Energy is ability to do work done. So the dimension of energy and work done both are same, and which is equal to M L square minus 2. Both are work done. Basically energy is the ability to do some work, and work done when we applied force and it's displaced in the displacement in the direction of force. So the both quantities are equal in dimensions. Energy and work done, they have same dimension. Now let me proceed towards an example, and in paper the examiner may ask question about an equation and say that is it dimensionally correct or incorrect. In your exercise there is also a question E is equal to mc square. Is it dimensionally correct or incorrect? So you know this is a famous Einstein equation, and dimension is used to find the correctness of an equation in physics. So we also use dimension for finding this equation is correct or incorrect. So first of all, we use the dimension of energy, we use the dimension of mass, and we use the dimension of c square. So this is left hand side and this is right hand side. First of all, we solve the left hand side, which is equal to dimension of energy. So in last we used dimension and work done both are equal. So the dimension of work done is m l square t minus 2. This is we find earlier the dimension of energy and work done both are equal, so we can use the dimension of work done here for energy. And when we solve the right hand side, you know the dimension of mass is equal to capital M, and C is used for in terms of speed. So the dimension of C is LT minus 1, and this is there we use square, which is because C is in square. So this formula becomes, when we multiply these two in a brackets, that it becomes L square T minus 2. So we put these values, we put these all values in this equation 1. So this equation 1 becomes, first we write the dimension of E. This is the dimension of E, m L square T minus 2, which is equal to, this is the dimension of capital M, that is mass, and L square T minus 2. This is the dimension of C square. So both sides are equal. So we can say that this equation, when the left hand side is equal to right hand side, it's mean this equation is dimensionally correct. So the famous Einstein equation is dimensionally correct. So in this way we find the dimension of an equation. Next example, which is in your exercise, find the units and the dimension for find the value units of g, that is gravitational constant. We find the units and the dimension. So you know that in gravitational law, force is equal to capital G, m1, m2, these are masses, divided by r square. So this is the equation, and from this equation we find the units of G and the dimension of G. So first we cross multiply for finding the value of G. So here f r square divided by, we get m1 m2, that is equal to G. So you know that for finding the units, you know that the units of I can write the units in terms of base quantity, not in terms of special units. We use special unit force in terms of unit in newtons. So we can write the base unit for these. So the base unit for force is, which is called MA, and that is equal to kg meter per second square. This is the unit of force, and for r square, that is meter square divided by masses in terms of both are equal, so that is equal to kg square, and this is g. So for unit of g, g is equal to kg, that is plus 1, and that kg becomes negative, and meter, that is meter cube, and that is per second square. So the unit of g is kg per kg meter cube per second square. So these are the units of capital G. Now for dimension, we say that we write the dimension for these three quantities. So we can write the dimension of kg, that is equal to capital M and its power minus 1 as it is. For meter we use L cube, and for second we use T, and the power is minus 2. So the dimension of G is M minus 1 L cube T minus 2. So this is the dimension of G. So we can find the dimension for any constant, for any value, for any physical quantity. So in these two topics, or in these two examples, we can find how a dimension find the values of for identifying the nature of different physical quantity.
Start.
Now, dear students, I am assigning you a homework or a task. You find about the topic dimension. You find the first assignment is prove that this equation is dimensionally correct. I am writing the equation S is equal to VIT plus half A T square. So you find, is this dimensionally correct? Is this equation is correct, dimensionally correct? And the second question is, find the dimension of Planck's constant. You know that H is equal to E over F. So you know F is the frequency, and you find this in terms of time. So these two are your assignment, and for your next topic you study the topic which is called uncertainty or uncertainties in calculation. Okay, thank you students.